want to have a look at z-scores, and I think that this kind of explains it well here. We're going to have a look at this question in a few minutes to do with Albert Einstein. But just to reiterate, a measure of relative standing is a z-score. It's one of the things that we look at. Percentiles you also look at, and that's pretty straightforward. You've already looked at a percentile from the maths that you've studied. The median is the 50th percentile. If you land on the median, you know, let's say in a test, it comes back in your DATS results or whatever that you land in the 50th percentile for maths, then, you know, 50% of the population are below you in their maths and 50% of the population are above you in their maths. It's not that you got 50% in a maths test, it's where you stand relative to everybody else. So another measure of relative standing is a z-score, and you probably aren't familiar with that. Most people are not familiar with that. So to explain it then, so that hopefully you'll have a fair understanding of what's going on, we're given this information here. IQ scores have a mean of 100 and a standard deviation of 16. Albert Einstein had an IQ of 160. Now we all obviously know Albert Einstein. We imagine, I'm sure, that his IQ is really, 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 really high in relation to the population. And we're going to keep that in mind as we go through the question. So IQ scores have a mean of 100. Now that doesn't say, oh, I took a sample of people and I got the mean of the sample. No, this is the mean of the population. Again, I don't know where they might have gotten this data from, maybe a census, I've no idea. But someone has collected this data, the mean of the whole population, they have an IQ of 100. So hopefully from the last one, you know that the mean of a population symbol is this here, and we call it mu. Standard deviation is 16. Again, it doesn't say, oh, I surveyed a sample of people and the standard deviation of the sample was 16. No, it's a population. So in the last one here, I didn't mention the symbols. So if you do the standard deviation and it came from the whole population, then we use kind of some version of that symbol. Maybe not a great, I'm not great at doing the symbol. And then S if it's from a sample. The standard deviation of a sample is this. Maybe a little bit better there. Okay, so now we start answering the questions here. What is the difference between Einstein's score and the mean? Well, what's the difference? Difference just means subtract. So we have from 100 up to 160, so that's 60. So his IQ is 60 above the mean. How many standard deviations was his IQ from the mean? So if we look at it, mean 100, is he, you know, if I add 16, that's one standard deviation above the mean. Well, yeah, he's well above that. Let's add another 16. That's two standard deviations above the mean. No, he's still above that. Add another 16. That's three standard deviations above the mean. No, he's still above that. Go again. Okay, so he's below 164. So he's 3 and a good bit standard deviations above the mean. So 3 and 3/4. Yeah, or 3.75. So you can work that out. 3.75 standard deviations above the mean. Next thing, convert his IQ to a z-score. So if I want to go to a z-score, go to my log tables. Here's my formula for the z-score, or it's called a standardizing formula. A z-score of a population. So we can see X is your variable. You know, in this situation, the person's IQ that we know is Einstein, minus mu, which is the mean of the population. When we look at it, it was 100. All over the standard deviation of the population, which was 16. So we want to create a z-score. Z equals x minus mu all over standard deviation. So Einstein's score is 160 minus the 100 all over 16. I'll throw that into the calculator and I end up with 3.75. So again, that's the answer that I got for part 2. So that is what a z-score is. A z-score is just how many standard deviations above the mean you fall. And then, was Einstein's IQ usual or unusual? Well, we'd know this probably from even looking at the maths. You know, we know about Albert Einstein, extremely intelligent. So was it, of course it was unusual. So we need to kind of use that information to look this up. And we go to our log tables and we turn over to find our z-scores here. This is probabilities for the standard normal distribution. Now, are IQs standardized? So is the histogram that you would get going to look like this shape here? And it is like, you know, the height of the population is going to be this normal symmetrical curve here. The weight of the population is going to be a normal curve here as well, symmetrical. So we're looking for Z here. And if we start looking down here, so if you're 0 Z scores away from the standard, if you're 0 Z scores away, it means that you're no standard deviations, you're 0 standard deviations away from the mean. So you're right on the mean there. And that's why we have 0.5, so 50%. This is like your median here. And you have 50% of the population below you and the full 50% of the population above you. Okay. So we're scanning down here. Now we're at 1 Z score. So if you're 1 Z score above the mean, that means you're 1 standard deviation above the mean, which is about here. And when you look at that, there's 84.13% of the population below you, which means, you know, about 15 point something of the population above you. So that's what we're looking at. Learn how to read these log tables will become important. 2 Z scores. If you were 2 Z scores above the mean, that means that you are 97% of the population are below you. And if we look down here, 3 standard deviations, and that means that you have 99% of the population, well, more than that. So you can tell where Albert Einstein lies, even just looking at that off the scales.